Okay, in this video we're going to be looking at sketching e to the x, but we have transformed the graph somehow. So what I want to highlight here is the location of any asymptotes and any key points on the curve that we should know about. So let's look at y is equal to 5e to the x. So first of all, identify what sort of transformation it is. This is a stretch in the y direction by a factor of 5. So the regular curve of e to the x has been stretched from the x-axis upwards and downwards. Okay? And so it would appear something like this, where originally it was going through 1 on the y-axis, it would now be going through 5, because it's a stretch of factor 5. Okay? If we look at y is equal to 3e to the x plus 1, then what's happened is that first of all we've got that plus 1. So the graph itself has been pushed upwards. It's been translated upwards. And so as there was a horizontal asymptote of the x-axis, y equals 0 for this one, as e to the x would have, the asymptote itself has also moved. And so the asymptote, horizontal asymptote, is at y is equal to 1. And then you've got 3e to the x. And so there's also a stretch by a factor of 3 involved. Okay, so the original e to the x curve has also been stretched. So when x is 0, we have 3 lots of 1. So e to the 0 is 1, so 3 lots of 1 plus 1 is 4. And so it would be going through 4 on the y-axis. Y is equal to e to the minus x. Now that is a reflection, because we can see that there is a minus in front of the x. And remember, that's a reflection in the y-axis. And so the curve would look something like this. So instead of the regular, like that. Okay? So that would be y is equal to e to the minus x, and it would be going through 1 on the y-axis. Now, if we're looking at y is equal to 5e to the minus x minus 2, then what's happened is that minus 2 has taken the graph down 2 places. Okay, so it's been translated by 2 in the y direction downwards. And so there is now a horizontal asymptote of y is equal to minus 2. So this asymptote that was there has been pushed downwards. When x is 0, we get 5 take away 2, so 3. So we know that the curve crosses through 3. And so the curve would look something like this, crossing through 3. The only point that we don't know is that point where it crosses the x-axis. Now that's when y is 0. So if we put 0 is equal to 5e to the minus x minus 2, add 2 to both sides, divide both sides by 5, and then you can log both sides. So log of 2/5 is equal to minus x. So that means that x is equal to minus log of 2/5. Okay? Now that minus sign can be brought up there, so minus 1, so it's 2/5 to the minus 1, so that'd be log of 5/2. So this is log of 5/2 there. Okay? Finally, we've got y is equal to 2 to the x. Now that is a stretch because the number is in front of the x. Okay, it's a stretch in the parallel to the x-axis, or stretch in the x direction, by a factor of 1/2. Okay, 1 over k, remember. So 1 over k is 2. And so k must be 1/2. So it's a stretch by a factor of 1/2 in that x direction. Okay, so that's pushing the graph inwards. And so the curve would look something like this. It would still be going through 1 on the y-axis. The original e to the x curve would look something like this in comparison. Okay? So the new curve has been pushed inwards by a factor of 1/2. And so that is how we would sketch each of these curves.